Okay, welcome back, folks. We're going to get started with trig identities. This is what we talked about in class today. Share screen. Okay, we did some examples early on that just kind of talked about finding common denominators. That's how we started class, and that's the first couple sets of notes. But what I wanted to go over was some of the identities that we're going to deal with. So if we look over here, everybody got a copy of this who was here. If you weren't, just make sure you see me so I can get you a copy of this. It's on cardstock. These are some of the reciprocals. Some of the ones you already know. Sine of x is the reciprocal of cosecant. So cosecant of x is a reciprocal of sine. Cosine with secant, secant cosine, tangent, cotangent. And then we did the quotients, which tangent is sine divided by cosine, and cotangent is the inverse, which is cosine divided by sine. So what we're going to do is we're going to use some of these reciprocals, these identities, to solve or simplify some problems. And then we had some Pythagoreans. And the way you want to look at these Pythagoreans is these three right here. So 1, 2, 3 are three Pythagorean identities that are true. They have to deal with sines and cosines and cosecants and secants and cotangents and tangents in one. So this is our first one, is that the sine squared of a number plus the cosine squared of a number equals 1. And then the other two are just kind of manipulating this. So if you think about it, if I wanted to solve for sine, I would subtract cosine squared. So again, what I'm saying is if I had, sine squared x plus cosine squared x equals 1, and I wanted to solve for sine, what I would do is I'd subtract cosine from both sides. So minus cosine squared minus cosine squared of x. I will get rid of it. So we would say that sine squared x equals 1 minus cosine squared x. That's all this is, and that's all the other one is. It's solving for cosine. And the same things happens for tangents and cotangents. Again, it's just three different ways of representing the same identity. So what ends up happening is we did a bunch of these problems in class. So what you're going to do is to simplify the following. Sine and cosecant, you want to get it in kind of like terms, if you will. So if you think about sine of theta, the cosecant is 1 over the sine of theta. And what ends up happening is if we have a number in the numerator and the same value in the denominator, they divide out the 1. The answer to this one is everything equals 1. Tangent theta times cotangent theta. Tangent is sine theta over cosine theta times cosine theta. Again, notice we have a cosine in the denominator, cosine in the numerator. They will go ahead and cancel out or divide out. And this gives me an answer of sine theta. Tangent theta, again, sine theta over cosine theta. The cosecant of theta is 1 over sine theta. We got the sine up top, we got the sine down below. So we end up with 1 over cosine theta, which is also known as secant theta, which is another way. So either one of these are acceptable representations. Okay, 1 over cotangent theta. What I'm going to do is I'm going to look over here and see if I see it on there. Bingo, 1 over cotangent of x equals the cosecant of x. So this is equal to the cosecant squared of theta, right from, and it's an identity. So we can get that right away. Then this one right here, again, there's a lot of ways to think about it. There's some reciprocals here, but if you're ever unsure, just expand them out in terms of sine and cosine. So that first term, sine theta over 1, the tangent of theta is going to be sine theta over cosine theta. Cotangent of theta is cosine theta over sine theta. And cosecant is 1 over sine theta. And if you notice, there's lots of numerator denominators. So those divide out to 1. These signs divide out to 1. These signs divide out to 1. And this thing ends up equaling 1. Because of all the reciprocal rules, these two are reciprocals of each other. That's tan and cotan. The sine and the cosecant are reciprocals of one another. So reciprocals are always going to give you a product of 1. Okay, tangent squared theta over secant squared theta minus 1. Again, go back to your identities. If we look here, secant squared theta minus 1 is equal to tangent squared of theta or x. So what I can do is I can actually rewrite this as tangent squared theta. This guy down below could be rewritten as tangent squared theta, a number divided by itself. This also equals 1. Okay, we want to keep going. We did like the first 9 in class. The next one, sine squared plus cosine squared. right here, sine squared plus cosine squared is a very common one. Sine squared times cosine squared gives me 1 over cosine squared theta. And 1 over cosine is the same as secant, so this is secant squared theta. Now this one's secant theta minus sine theta tangent theta. Again, this is one we're going to have to expand it out, turn it into sines and cosines. So 1 minus cosine theta minus sine theta over 1 times sine theta over cosine theta, sine tangent. Now in this one, we're going to just do some combinations because there's no rule that we use. So this is going to become sine times sine, which gives me sine squared theta over cosine theta. Common denominator, which means I can bring it back together. So 1 minus sine squared theta over cosine theta. 1 minus sine squared theta is equal to cosine squared theta. So this equals cosine squared theta over cosine theta. And much like if I looked at x squared divided by x and got x because I subtract the exponents, a cosine squared divided by a cosine is going to equal cosine theta when I divide that out. Last but not least, secant squared theta minus 1. Secant squared theta minus 1 is tangent squared theta. So this guy up top becomes tangent squared theta over secant squared theta. Turn it into my sines and cosines, or another way to think about it is this. You can do tangent squared theta times 1 over secant squared theta. Tangent squared theta is sine squared theta over cosine squared theta. Secant has to do with cosine. So it's going to be 1 over cosine squared theta. And since it's 1 over this one, this is actually going to be the same as sine squared theta over cosine squared theta times cosine squared theta, because when I'm divide by a fraction, I multiply by the reciprocal. Those cancel out. I'm left with sine squared theta. Sine squared theta. So we did those 9 in class. I think I got through one more in another class, but what we're going to do is just keep working these out. But again, the biggest thing is anytime you see one of these squared things, a lot of times you want to kind of think about the Pythagorean rule. So anytime you see a square, think of the Pythagorean rule. Otherwise, kind of put it into one of these identity forms, and most often things will go ahead and cancel out. So again, what I'm going to be talking about from here on out is this. I'm not grading the reflection anymore. What I'm using it is for you to give me feedback. So if you have questions, please use it as a chance to give me feedback. I'm going to try and keep doing these videos every day. So if you're out for any reason, you can watch it, or even if you're in class, you can kind of review. Have a nice day.